Hello, P plus Q equals to 8, PQ equals to 48. How do we find the value of P and Q? Solution. We have P plus Q equal to 8 and PQ equal to 48. Let's call this the first equation and let's call this the second equation. From equation 1, we have P plus Q equal to 8. Suppose we transfer this guy to the right side, so we're gonna have P equal to 8 minus Q. The next step we are going to take now is to replace this P with this guy. So we're gonna have 8 minus Q times Q equal to 48. We just replace this P with this guy. So let's proceed further. 8 times Q, that is 8Q, minus Q times Q, that is negative Q square, equal to 48. This implies that Q square minus 8Q plus 48 equal to 0. When we transfer each of this guy to the right side, let's proceed further. You will observe that this quadratic equation, we can solve it using quadratic formula. So our A here is 1 and our B is negative 8, which is the coefficient of Q, and our C is 48. What does the quadratic formula says? It says Q equal to minus B plus or minus square root of B to the power of 2 minus 4 times A times C all over 2A. Q equal to minus, what is B? B is negative 8. We have negative 8 plus or minus square root of, what is B? B is negative 8. That will be minus 8 to the power of 2 minus 4. What is A? A is 1. So we have times 1 times, what is C? C is 48 all over 2 times 1. Let's proceed further. Q equal to minus times minus 8, that is 8, plus or minus square root of minus 8 to the power of 2 is 64, minus 4 times 1 times 48, that is simply 192, all over 2 times 1, that is 2. So we have Q equal to 8 plus or minus square root of 64 minus 192 is negative 128 all over 2. Let's proceed further. Q equal to 8 plus or minus. We can rewrite this guy as square root of 128 times square root of negative 1 over 2. Let's proceed further. Q equal to 8 plus or minus square root of 128. This guy, square root of negative 1 is I from the complex number, all over 2. Q equal to 8 plus or minus square root of 128. We can rewrite it as square root of 64 times square root of 2 times I, all over 2. Q equal to 8 plus or minus square root of 64 is simply 8 times square root of 2 times I, all over 2. So we have Q equal to, it is possible to pull out 2 from this numerator. Doing that, we're going to have 2 into 4 plus or minus 4 root 2I all over 2. Clearly, this guy cancel each other, so we are left with Q equal to 4 plus or minus 4 root 2I. This implies that Q equal to 4 plus 4 root 2I or 4 minus 4 root 2I. Thus, we have two values for Q. We can use each of this guy to get the other values for P. So let's do that. Let us continue since P plus Q equal to 8. This comes from equation 1. If we try to transfer this guy to the right, we're going to have P equal to 8 minus Q. Now, let's consider when Q equal to this guy, when Q equal to 4 plus 4 root 2I. So what will be the value of P? P equal to 8 minus, what is Q? This is Q now. 4 plus 4 root 2I. P equal to 8 minus times 4, that is negative 4. Minus times this guy, that is negative 4 root 2I. So P equal to 8 minus 4, that is 4, minus 4 root 2I. Thus, the first solution, which is P comma Q, is equal to, what is P? This is P, 4 minus 4 root 2I, comma, what is Q? This is the value of Q, 4 plus 4 root 2I. This is the first solution. Now, let us consider the case when Q equal to this guy, 4 minus 4 root 2I, when when Q equal to 4 minus 4 root 2I. So, P equal to 8 minus Q from this guy, this line. So, let's proceed further. So, P equal to 8 minus, what is Q? This is Q, 4 minus 4 root 2I. This implies that P equal to 8 minus times 4, that is minus 4, minus times this guy, that is plus 4 root 2I. So we have P equal to 8 minus 4, that is 4, plus 4 root 2I. Thus, the second solution, which is P comma Q, is equal to, what is P? This is P, 4 plus 4 root 2I, comma, what is Q? This is Q, 4 minus 4 root 2I. This is the second solution for the value of P and Q. That's it. Thanks for watching.